All right. Hello, everybody. Good morning, good evening, good afternoon, and thank you for joining this Neo4j Live. Today, topic is Advancing GraphRAG, Text, Images, and Audio for Multimodal Intelligence. And I'm very happy to have Amy Hodler as my guest. Hi, Amy. How are you doing?
I'm doing well. Thanks for having me, Alexander. It's always a pleasure to talk with you.
It is absolutely. Thank you very much. Likewise, totally likewise. It's been a while. You've been
Mm.
busy in the past, but you've been I think also famously, I think going back a couple of years now, probably 5 years or something, you wrote a graph algorithms book together with Mark Needham.
Mhm.
Was like your not your first publication, but I would say the start of your graph, maybe your graph journey a little bit more.
Yeah, it
And
actually was my first publication, and it was
it
just
was your
a it
first
was just a
publication.
joy
All
to
right.
write.
Okay.
Yeah, it was.
Okay. Good.
So yay. Yeah.
Yeah. Cool. Yeah, that's great. And it's still relevant. I think in terms of content as the graph algorithms. But
Mhm.
you
Mhm.
kept part of the graph ecosystem, part of the graph world.
Mhm.
You are one of the, I think, organizers or initiators of the Graph Geeks community, which I'll post a link to in the channel as well.
Excellent. Yeah, yeah. So Alexander, I think since we last spoke, I've been on a bit of a journey. I have wiggled away occasionally from some graph elements, and just find that it always brings me back because there's
Yeah.
nothing more interesting than how things are connected. And I would say in today's world where the connections are just getting more complex, there's nothing like a graph to really understand like what's really important in something. So I just keep coming back to graphs. Like, it does not matter how far I wander, I come back. And that was part of founding Graph Geeks. And I jokingly tell people I started that because I was lonely, but I'll say I was graph lonely. So I
Yeah.
missed all of the graph activity and my graph friends. And I thought, well, if I can do nothing else, I will start a community for anybody doing any graph anywhere. I don't care what their, what the technology is, or, if they're doing it on a paper and spreadsheet. We'll bring it together. And so that's how Graph Geek started. And now we
Oh,
have
cool.
about 700 people on Discord, and people
Nice.
offline as well, playing and just enjoying it. So it's been a really nice journey.
Yeah. Yeah, that's great. No, it's a great effort. Also, as one of the members, and also obviously the part of the graph
Mhm.
as a whole, I guess it's really great to see that, and to where people share their experiences, where people can talk about what they're doing,
Mhm.
and where people are actually fans of the technology. Like you say, you come back, and we've seen this a lot in when we look at
Mhm.
forums or at Discord, someone will say, "Hey, I have been watching this for a while, but now I have a use case
Mhm.
here, or I have been in silent mode for a while, but I always wanted to do something, and
Mhm.
now I'm back." And so it's
Yeah.
yeah, it's a
Mhm.
same experience we see quite a lot. That's
Yeah.
great to hear. Um, yeah, so maybe I guess we jumped right into introduction. So I don't know if you want to say a few words about what you do outside of obviously Graph Geeks and writing that graph algorithms book back in the day. Do you want to give the audience a bit more about yourself, Amy?
Yeah, so I was just, as you were saying that, I'm like, what do I do outside of the graph world? So outside of Graph
Or
Geeks
inside the graph
and
world, it's
graph
also fine.
graph
Yeah.
conferences, some of the fun things that I've been looking at lately are using graphs for investigative research, which is
Mhm.
really an interesting area. And just so that I can understand that a little more, and just do my own fun research. And then working with colleagues, either that I've worked with before or that are in Graph Geeks, on just exploring, I would say, new areas of using graphs. And that's a little bit of why we're talking today about multimodal GraphRAG, is kind of pushing the boundary of what's possible and hopefully putting these things out in the world. That's been really interested. I'm very interested in maybe some esoteric things that are coming, in the future, like hyperdimensional computing and hypervectors and what happens when you get these really large vectors, and then neuromorphic computing as well, which is important. Signal-based processing, so that we can reduce our energy footprint, especially when it comes to AI. So there's just a ton of cool stuff going on right now. That's a little bit of me on the techie world. For those that know me, I live in Washington State in a rural area, and enjoy being outside, bicycling, kayaking, things like that. So that's when I'm not doing graphy stuff.
Yeah. Yeah, that's very nice. Yeah, I like that. When we briefly talked, I shared that I oftentimes visit my girlfriend's farm, and that's always like nice to go outside and then leave the laptop behind and just grab a shovel or grab something else and do some work with your hands.
Yeah, absolutely.
I think it's a good balance between thinking and working.
Absolutely.
Cool. So yeah, the topic is advancing GraphRAG. I initially asked in chat just if anybody where people are coming from, and if they did some experiments with GraphRAG, or if anybody built already something with GraphRAG. I think the majority of people said not yet. Here one person said, Cindy from Germany, said they experimented with GraphRAG but haven't developed anything. And some other people say that they look into it but haven't done so. So I think we have a mixed audience, but basically I think more people haven't done much with GraphRAG than what they have done. And we are taking one step further even now in talking about getting this multimodal intelligence thing. I think you called it mmGraphRAG. Is that your coinage, or is that?
That started with David Hughes, who is the I would say the brainchild of putting all of this together, coining it. We were just struggling with after GraphRAG, what do you do when you want multimodal GraphRAG? Yeah, and if anybody has a better name, let me know, because that is we're not exactly happy with the name, but for lack of a better name, there we go. It's descriptive. But I do think for people just getting started with GraphRAG, it has proven to be very valuable. Your team, Alexander, has a lot of great information on how to get started with it, and how it can really add in more accuracy, but also guardrails. So I think there's just a lot out there. The one thing I will say, if you are getting started, remember garbage in, garbage out. You got to start with a good graph to have good GraphRAG. And, if you're not doing things like entity resolution, then you're probably not starting with a good graph. So that would be my, 20-second tip. If you're just getting started, look at the Neo4j information and make sure you start with a good graph. That's kind of like baseline.
Yeah. I think that is, yeah. I don't know, so true, because you have this problem, especially in you have it everywhere, but in with AI, it's just so easy to think, okay, everything will be fine. I'll just put something there, and then I do something, and then the AI will take care of all of it. But it just won't. If it's like you said, if it's garbage in, it's gonna be garbage out. You cannot expect it to know what you want it to do for you. You cannot expect it to filter all your garbage for you and then expect you to do at some point you have to do that. You have to spend a little time and think, okay, is this really what I want? Is this really what I need? This should go in, and this should not go in, and then you get a result that is actually worth working with in the end.
Yeah.
So I shared the link to the Neo4j genai ecosystem in chat. So that's one page. There's another page that's graphrag.com, which is another great a great overview page for people to start, which I also put in chat. So so you can look at that. later on. So that's, I think, a couple of resources that are good to, look into and start, exploring and reading up on. And then there's tons of content out there, videos like this today or other videos which we did on the Neo4j channel, but on other channels as well. So I think there's a good amount of content, from getting started guides to more advanced things across the internet. So, but today we want to talk a bit about the advanced GraphRAG part. So, yeah, you have developed this concept, or together with David, I guess, thought about this. Okay, what can we do? We have started with GraphRAGs, but where does it go? Where does it move next? So what's your thinking here?
Yeah, so I probably should explain what the heck I mean by multimodal GraphRAG, and maybe as part of that, a little bit of like why we were motivated to play with that. I think in a very high level, multimodal GraphRAG is about adding in not just text, but also image data and eventually audio data into your graph for GraphRAG. And then capturing the context and the relationships between things like graphs naturally do it, but adding in those other data types so you can enrich it further. So I guess the good news for folks is there's a really well pointed path to get started with GraphRAG. But it's not, and when you get started, that's not necessarily the end point. Like there is more advancement that we're proving out works really well, and that I'm sure other people will add in more detail to and add their own flavor on it. But I guess the good news is it's not just a one and done. It's like, hey, I do this once and and we're done getting benefit. Like there's a path to add in more than just textual lexical information. You can add in more. And when we think about the motivation, I often think about that phrase, a picture's worth 1,000 words. And you think about all of the information, this like latent information that is in images and audio that is hard to describe. And or you can describe it, but you don't have necessarily the relationship of subcomponents. So I'm looking at your image right now, Alexander, and I can describe that you're in a room and you've got a couple photos behind you, and I can talk about that, but actually graphing the relationships between the subcomponents in an image isn't something that's easily done, and not very often done in a graph. And that information, and maybe if we're talking about audio as well, maybe the tone of your voice as well tells me things that for the most part we're just kind of leaving behind because it's difficult to categorize and put in in this case a graph. So GraphRAG allows us to decompose different types of data and then look at the relationships from them when you're talking about multimodal GraphRAG. And so the ability to improve things like search, to be able to customize things for specific domain knowledge is quite significant. But quite frankly, we just started with like, hey, there's this data types we're not used to using. Maybe we can use that for GraphRAG. Let's see what happens. And you can imagine, like I think about search a lot because, I don't know if you like me, you're always Googling for something and you never get exactly what you're looking for. So if you Google something like bananas on a table, a little hungry right now. But if you're Googling bananas on a table, you probably get a whole bunch of images. How do you know what's the best image for you? Like you probably get, bananas on top of a table by themselves. Two bananas with a whole bunch of other things on the table. You might get bananas in a grocery bag on a table. All of those elements, if I, as a human, I'm looking through that going, yes, this works for me. This is what I want. This doesn't work for me. But how do you know which is the best? And it's the context that helps you figure out what the best is. And if you current GraphRAG doesn't really break down the components in an image, so you know that the banana is in a bag of groceries and the grocery bag is on top of the table. And so it doesn't break down to that level. you're not able to do things like search, not just text, but texture. Like you're looking for a picture of bananas on a rough surface of a table, maybe quality of the image, maybe the placement on the table. And so GraphRAG also doesn't work very well yet for things you don't have easy access to, or Google doesn't have easy access to if you're doing a Google. And so reasoning across these multiple levels of abstraction is where having multimodal or different data types can really help with. So you want to be able to abstract, to go deep when you want to get some kind of deep, very specific analysis, but then you also, and Graph's really good at this, walk up the hierarchy to be able to get a higher level abstraction and then reason across that. Because that's very much the way humans reason. So if we can break down those components, understand how they interact together, and understand the hierarchy, you're now blending like semantic context with text, visual, audio, and it just allows us to reason at those different abstracted levels. And so doing that is quite interesting. I hope that maybe answers maybe in a little more detail the question of why did we do this?
Yeah, no, it's interesting because I mean, when you talk about, getting information out of images or audio, you probably, the first thing you think about, okay, there's meta information I have or available. Maybe for a video I have, or an audio file, I obviously have the transcript. Yes. So I get the raw text. For an image, I get maybe a description. So some of these are very extensive and you get lots of details. Some are like, like you just described, okay, there are bananas on a table. I don't know, is the surface of the table, is it wooden, is it a metal table, are the bananas in a bowl, are the bananas ripe, are they green? I don't know. It's just it's very superficial maybe at some point, and it doesn't give me more information. Sometimes it does it, but sometimes it doesn't. So it's very interesting to think about, okay, there is more available in an image or in an audio that is not necessarily moved over if you have no, if you just take the raw information and don't have the audio to listen to, or you don't have the image yourself, you just take the meta information, you lose a lot of context.
Yeah, you basically, I mean, if I just think about, I'm a more visual person, so I think a lot about the visual elements, that you don't really have reasoning within image components that you might want. And, anybody who's got a graph background, you realize those things are relationships. One of the things I think a lot about is things like ships, analyzing like a group of ships going in a direction. I might be able to do a search on certain types of ships, maybe ships all in the same direction. But if we can understand the placements and like maybe how rough the water is around the ship, I can tell you which ship is moving faster than the other ones, and maybe one is about to overtake another one. Maybe they're working obviously in concert, maybe not. Things like that you want to have contextual reasoning within an image itself, or within an element itself. And so these kind of nuance reasoning or nuanced similarities that you can do with a graph is really impressive. And then if let's say your AI solution gives you a suggestion, you can actually track back with the graph what the explainability is, or what the reasoning actually was. So there's quite a bit of interesting things. And I guess some of the use cases that you might think about is like geospatial analysis. So find me red roofs in this area that happen to be near water, like in Boston, that are near water, something like that. And I'm looking for something very specific within the image itself. Or I think it has a lot of surveillance security applications, but also things like medical diagnosis. Like I'm looking for specific markers of visual abnormalities. And I'm all visual at the moment. Or another one that's a really interesting that some colleagues are speaking about is like IP searches. So internet or not internet, sorry, um, intellectual property searches. So for patent
Yeah.
searches, how do I compare it's something that I want to patent, a new design, against not just the metadata, but imagine the architectural diagrams that were included inside of the patent. And I want to look at the old ones, and maybe there's a correlation where it's like, these look awfully similar by the architectural diagram and the implication of what's in that architectural diagram, but not the text. What's going on here? Maybe they just described it differently. So there's all sorts of interesting use cases that can come out of this, which is fun. Like I said, we like to kind of push the boundary of what's possible.
Yeah. Yeah, and especially in medical, and now that you mentioned, I think this was one of these poster child use cases, exactly, where I think, okay, doctors are having to look at so many pictures of, let's say, cancer, and then okay, what's on the picture here? I have no idea, and maybe some of these patterns are easily recognizable, and then a doctor will spot them. Some of these patterns are harder to recognize, and especially in early stages, it's difficult to see differences between picture taken week 1, picture taken week 40 or something, and then there is some difference, or maybe even 1 and 10 already, and then an AI tool can map these against each other and can say, okay, there's been a change, and this is something to look at, which might easily be missed. So I think this is a great example of one of these use cases of connecting technology in this sense.
Yeah, absolutely. Yeah, it is an interesting space that's moving, quicker than I expected. I think maybe we say that about all technology right now. And I think the use cases are going to go beyond what I can even imagine right now, which is kind of the fun part of it.
Yeah, absolutely. I just want to read it out because it sounds like another very exciting use case that Bhavneet just shared in chat. Is they are trying to solve a problem of stitching text, image, and audio components such as genre or mood generated by music, and enabling business users to decide whether these are, going into the right direction and deliver an intended story. And I think that's like a perfect example, I think, for what we just described as the multimodal GraphRAG, because it's connecting all these things. It has the information about the text or the content of the video or the content of the audio piece, the music, let's say. It also gives the meta information that is directly inferable, but it also can go one step further and say, okay, this piece of music is of genre classical, but also is maybe upbeat, or is maybe sad or something, or is giving you a little bit of it goes into this and you know what I mean. And then same for an image. Okay, when you look at it, this is a funny scene, or this is a sad scene, or this is maybe a scary one, and this is what, like, the emotional aspects that are evoked as well is coming all together. So
yeah, and playing with image and audio with that in mind, it's interesting to see and use the graph algorithms to then see clusters. So you have communities of similar, or I call it like-minded, not necessarily similar, images or audio that are more evocative of, as you mentioned, emotion or a style, like 80s styles beach scene, or 80, a 1980s feel, images. And I think as people who are, I mean, I always thinking about search, but if you're a creator or a content creator, it can be very difficult to find the right type of image. Like, you could say, I'm looking for a beach scene with 3 people in it, but I really need something with a similar quality and feel to it, so the images don't look like they're all different styles, or the audio doesn't feel like, if you're scoring a movie, you don't want really different styles of the audio. You want a feeling about them, or something that has a common thread. And I think graphs do that really well. And when you can break down other types of data, then you can add it to your GraphRAG and your recommendations, and you can ask for something that has a similar style or feel based on this clustering that maybe isn't in the metadata itself. Which, yeah, I think that's a perfect example. Yeah, we actually played around with that, and style was an interesting one to pop out. I didn't expect that.
Yeah. Yeah, yeah. If you think of this, what's I think it's happened this week, last week, where ChatGPT or OpenAI released they updated 4.0 model where they now improved image creation, and everybody created these. I think I've seen lots of images of people creating themselves as a toy figurine, some kind of.
Have you done that? Wait.
No, I haven't. But
Okay.
it's like this, and then the before that, everybody created themselves as part of the Ghibli style image. So I guess this is a little bit part of it. Okay, you are now able to tell a AI tool that I want this image to be taken into this other style, and then I'm pretty sure you could say, okay, make it so that it is evoking emotions as well at some point. I guess, okay, this is the outcome I want here is funny, or the outcome I want here is scary or something, and then you go even further down this customizable pathway. But this is image generating from the LLM. But if you have your own data, right? I mean, you always have to think about, okay, what if I'm already an artist, or if I'm having a library of assets, I want them to be part of this AI application. I want them to be cataloged, and I want them to be made available, but not to the public, obviously, but maybe to my internal stakeholders. And I want make available, okay, here's a video that is funny. Here is a music piece that is, upbeat or something, and all this information, then generate something from there. That's more difficult, I would say, because it is your intrinsic data that is probably not not stored that an LLM can access it. You have it, in the raw file somewhere, but you lack the information to connect these information.
We've been talking a lot about the ability to, which I still think is fairly unique, is to understand the relationships within components, which could be an image, it could be an audio, it could be spatial relationship, or probably frequency relationship, tone relationship in an audio. But I think you bring up a really good point, is there's also, even if you could find something via a Google or an LLM chat, that that's not your offline use that you may need, and you may want and need to have data that is not shared with the rest of the world, so that's secure, self-contained environment. And then also domain, a knowledge integration as well. So a lot of very generalized searches, or generalized chat responses aren't exactly what you might need in a highly specialized, or regulated environment. And so having that offline capabilities is just really essential. And then of course graphs are just really good for helping with explainability as well. And so you kind of bring in all of those capabilities and reasoning as well, that that you might not get in other types of solutions, or I guess RAG without the graph.
Yeah. I don't know. Do we want to talk a little bit how this can be done? I mean, at least in broad strokes, or do you have?
Sure. Yeah, why don't I share? We are presenting on this topic, just for those of you that might be going to the Knowledge Graph conference in a few weeks, or the Open Data Science conference. We're going to present a little more detail. So, but I can definitely show you at a very high level. Here we go. Of course, I have slides. So I can't give everything away here, but I can definitely share a few slides. So I usually try to start off with, like, okay, level set. What are we really doing? And it's we're really a couple different phases of how you get to multimodal GraphRAG, and this is more on the visual bits, but it's, kind of similar process. And basically, first we're just shredding and breaking down images or audio into the subcomponents. So those are our tools. There are tools out there. There's quite a bit, and we're using a couple open source ones. But to break it down into the subcomponents and how they're related, and generating captions for those. So we do, obviously we need to have some, text that goes with that. Then you take those components and subcomponents and load them into a graph with their relationships. And again, is it to the left of it? Is it to the right of it? What's the texture of it? What are the different elements and different relationships? So relationships of one
Mhm.
image to another image, within an image, and we do that so we can preserve the context. And then we use an embedding space. So we are using vector embeddings to kind of anchor um, the elements in there, so we can do more global search in the graph and have semantic search as well. And then we provide the results to your LLM so that it can have that full context. And that's actually what we're calling associative intelligence. Again, we'll see if it takes off that term. But the
Hmm.
idea that you get associations versus exact matches is one of the things that's fairly unique, so that you don't have to find an exact match. You can find something that's similar to that. And I think I have let me see. I probably have a nice graphic of what that looks like. Yeah, yay, I do. Okay,
Oh,
so
cool.
this is just a quick screenshot, but you get these little images, and this can rotate in 3D. Sorry, it's small. We could do this another time with the full demo, but you basically have different axes that you're looking at your data, and here's a bunch of bananas sitting atop a wooden table. How is that similar to other images? So you have this ability to have similarity versus an association versus exact matches. So it's pretty interesting to be able to do that. But getting back to the how the heck do we do that? Let me see here. Good, I do have this. So there's a couple different layers or levels. I guess architectural layers, and it really starts with kind of at the high level. The architecture integrates like these different processes to have multimodal search and analytics. So you start with this data extraction and embedding, where pre-trained in this well, in the visual one, vision models, but pre-trained models analyze the data to extract the different features we're going to use, and then we transform those into vectors. And this, bottom step, it really kind of ensures that we collect that rich semantic content, and then are able to represent it. And then the semantic level, I would say semantic and graph construction, that really organizes these extracted vectors and relationships into both vector and graph databases. So in our solution, we're using both a vector database and a graph database together. And nodes are connected to represent the features, metadata, and the text-based context, because we still want to have lexical content. And then so that provides us a framework for associations in semantic reasoning. And together, these different components kind of form what I would say is the backbone of multimodal GraphRAG, and able to give us that bridge between, I would say, textual data and non-text data. Is we're so used to dealing with textual data, but being able to bridge, and this is to me where it gets exciting, because there are a lot of models out there that will train on visual, train on audio, train on text, but be able to give the bridge, and graphs are just so good for that. Be able to give us this bridge between these different worlds in a way that's actually meaningful. And then, of course, we have this, like, I would say, the query level, or where your applications would hook into, and that uses vector similarity searches to identify like what's most relevant in the data, and then we couple that with graph queries to retrieve detailed kind of contextual relationships and metadata. And this is again where I probably did a bad job of it explaining it earlier, where I talked about being able to have multiple levels of abstraction that you can reason about. We want to reason on two levels. One, a global level, like what's associated similar up here. And then once we dive in, we want to understand like what's most prominent, what's the page rank, what's the, what's where the cluster's at. And so you want to be able to hop between, didn't mean that as a joke, but anyhow, hop between high level abstractions and then detail in it. And, that ability to go back and forth and bridge that gap really also helps us with the interpretability as well, and just kind of gives the language model a little more transparency when it's doing results. So that's kind of the high level how to. And as I said, we are presenting at a couple conferences to go a little more into the detail, and we have some open notebooks which I didn't provide ahead of time, but I'll get those to you as well, Alexander.
Super. Yeah, you can if you share them, and then you can put them in the YouTube video description, and people can explore. So that's cool. We got a couple of questions, so maybe we take those on. So Avneet asks, when you said you were destroy the pixel, or say rip the picture apart on pixel level, I would say, maybe. So when you do that, she asks, is the various component extracted from an image, is that linked back to what the overall picture would say, or how would you structure? What's the structure like, I guess, is the question from I mean, a pixel is probably just having information about a color. Okay, so this is a red pixel. I don't know that it is part of a book, maybe that has a red cover or something. So is it how is that connected in the graph, and what information is stored where, I guess?
So it could be stored in different ways. And this is new work, so I would imagine for different uses and different people are going to use these things differently. Basically what we did, we were using the COCO data set. It's just how we got started, and CLIP. And we wanted to create this like workflow, and we actually ended up using BAML for those of you who are playing with that to create that workflow. But we ended up using I think Llama 3 to do some tasks, but not create the captions. And so we ended up using a couple different. We ended up switching to Microsoft 3.5 with Olama, to take advantage of some of the workflows with BAML to kind of rip some of this information out, not going down to the pixel level, but the subcomponent level. And maybe I wonder. I think I do have. Oh, that's the one we saw. Here we go. That's a little better. Actually, that's still hard to see. Here, that's a little better. So there's a lot of customization that you can actually do this way. And so in this case, we have an object, and we have the image itself. So the little, if you can see that very well, sorry, apologize if you can't, but the little yellow image is the image itself. Like, maybe it's a, image, in this case, ID, COCO IDs right there. So it's an ID of the image, and then you have objects within the image. So you have instances of an object. So you might have an object or an image with like 4 people, and each one of those might be considered an object instance. And the amount of granularity you go is really up to you and up to the tools that you have. One of the things that I am curious to see is where's the line of effectiveness versus noise. At what how deep do you want to go? And it probably changes if you're looking at pictures for a magazine that you're creating. You're looking for images in a magazine. Probably don't need to go as granular as you would for like a medical image. So that's going to change. But you can, and so you can structure. What we did is look at like just the main components in the image, And then the objects, those objects, what instances where they were actually there in case they're there multiple times. And then a look at color. And we also looked at texture, which I don't think is shown here. But you can see kind of on the left, we've got texture value, texture description, complexity description, like how complex is an image? Is there a lot of patterns there? And then if you can see the little brown object instance, we also have above, below, left of, I think overlaps, so we can kind of see what objects are kind of clustered together. And then looking at things like color, we also looked at using strength and on
Mhm.
the color as well, like how strong, how dominant is that color. So you can look at dominant color scores as on the relationship or in the node itself. So again, this is new, and
Mhm.
we're getting really good, interesting results. But there are probably going to be experimentation and changes in the way people modify things for their own environment. So I wish there was a tried and true way, but I suspect
Mhm.
that quite frankly, we're going to see people customizing this for really different uses.
Yeah, I can imagine it's early stages still. Even in GraphRAG terms, I think people are still figuring out
Mm. Mhm.
what makes sense and what is the best way to going forward. So this is yet another level down, I would say, to see how
Mm.
it goes. So obviously,
Yeah.
and with all of these projects, I think it's always the unfortunate answer oftentimes is it depends, because it depends on what you are wanting to achieve, what your data looks like, what you are doing with it. But it also
Mhm.
depends on what what is your experience in the past, and then some people share a different way of moving forward, and then for what works for others doesn't necessarily have to work for somebody else. But it's always great, because I think particularly in this space, people are sharing what they're doing. People are experiencing this technology together, sort of, and then somebody says, "Hey, this works for me. This is great." Sharing it, lots of content, as we talked about earlier in the beginning, is what other people did, and it's great, and then you can pick it up and you can make it yourself and make it your own, basically, and
Mhm.
adjust it,
Mhm.
adapt it.
Yeah, and I'm really curious to play with this idea of what does it mean to have relationships in audio and video. Well, so we're talking about video. We're not doing that, but audio and images as well.
Mhm.
As somebody who loves graph algorithms, I often think about, well, what does PageRank or centrality really mean of images graphed and the relationships graphed within the subcomponents? Does it imply a feeling? Does it does it even make sense? That's the other thing. As I know
Yeah.
clustering makes sense from a lexical standpoint, and you think about all the centrality algorithms were developed in a social science standpoint. Does it
Mhm.
even make sense to apply them to images and audio? Maybe, maybe not. And that's the one of the fun things about graph analytics is, originally, these analytics techniques were developed for one area are now being applied to other areas very successfully. This is a whole open field of, can we apply it to audio, video, image, and does it really mean anything, or does it mean things that's just totally different than what we're used to from the social science standpoint? So to me, that's even a, if we want to get really weirdly philosophical in the graphy sense, that kind of gets very fun, as well as just kind of explore like where those boundaries are. I'm very interested in missing information as well. So, or information that's missing in one data type, but is there in another data type. And I think about watching or hearing. Hearing a scene or watching a movie where someone's sitting on a bench and you can hear the birds in the background, but there's no image of a bird. There's no
Okay.
do you
Yeah. Yeah.
do
Yeah. That's a
do
good
you
point.
add that because they're
Yeah.
related and you're hearing elements that are now missing in the other elements? Should you add it? As humans, we all know there's a bird. There's the session that we're going to give. There's a picture that I'd love to show, and I probably have it. Let's see if I can find it really quickly. This is one of my favorites, just because it always makes me laugh. There we go. This one always makes me laugh. So if anybody has kids, you know that there's a kid in the background that did this. Like it's just, we know there is more to this story, and this is just the image. And the text description of this doesn't mention a kid, doesn't mention that it was probably nighttime. It doesn't mention, any of that. Doesn't say silly, although maybe I could definitely, yeah, maybe that context AI could pull out. But these are the kind of, so I'm really fascinated with this idea of things that stories and things that we know as humans when we see something, because we have this world context that is, maybe in one element, but not that is missing in the other. Like if I were to make this into an animation or a video, you'd have a little kid giggling in the background.
For sure.
You'd have to do it. Yeah, right.
Yeah.
So yeah, and so those kind of things, I'm also fascinated with that, of when you can see things in one data type that's obviously missing it. Well, obviously might be missing it in another one. It's a lot of fun too.
Yeah, that's a great point. Again, to our earlier conversation about, okay, what's missing, what you don't see, what you don't see in the picture, what you don't hear in an audio track. It's like, okay, there's this lack of information, even if it's a very rich piece of content. You have a video, you have an audio file, you have an image, but still it's just, like a look through the keyhole almost. Like, okay, you see a little bit, but what's left and right is as a human, because you look at it, you understand what's going on, you grab the feeling, you grab emotions, you grab what's probably going to happen next, right? I mean, this is like why comic strips work or something like that, because you kind of like, or why jokes work, because you have something like, okay, I have an idea what's going to happen next, even if I don't see it on the image, but I know, okay, this is probably going to be funny, or this is probably going to be happening, and then it's funny because it doesn't happen, or something like that. But for an AI tool analyzing an image or a video clip or something, it's hard to say, because it's just, okay, this is the box you're looking at. The rest of it that we are inferring is just not there, and we have to put it there, I guess, through something like multimodal GraphRAG.
Yeah. I think just the amount of latent information we don't even know we take in as humans is amazing. And I don't know if we're going to make AI more funny or not, but maybe. But just, is the information's there, and there are a lot of tools out there. That's the other thing that's kind of interesting, is I feel like there are a lot of tools out there that can decompose image data, audio data, video data, but we haven't linked it all together yet. And that's, again, I think, and maybe we should just be calling it multimodal graph. But that's where this, starts to, and graphs are like naturally good at, linking and bringing in context. And it's interesting, as long as I've been in graph, I just didn't occur to me to be able to try to not just decompose the image data or decompose the audio data or the description data. It's like when you actually start to bring those things together in a way where there are bridges between them, I think that's where we're going to get this whole new, associative ability that is a little closer to, what humans do. So I'm pretty excited about it. There's obviously a long road ahead, but if you're getting into GraphRAG or getting into graphs, there's so much low hanging fruit. And I think we were just able to show with, I don't want to say very little work, because I will say, I think David Hughes did probably the lion's share of the heavy lifting, but with, in a short amount of time, prove that these tools that are out there, we can use graphs, to be bridges and vectors to help us with, with compressing the information, and just really do a lot more. Yeah.
Yeah, absolutely. I think it's a great segue maybe to one question that came in from Brandon. Brandon asks, have you found that LLMs with multimodal GraphRAG produce richer and or more nuanced responses in relation to the topic or entity being discussed? Or if so, have you been able to confirm that? Or rather, I guess the question is, what's it like performance-wise, or can we put a finger on this is better than the other?
I would say we have seen improved results and definitely improved performance. We have not benchmarked it. It's one of the discussions we have on, okay, is it time to do a white paper? Neither one of us have an academic background, so it's a little, the idea is like a little daunting to go through a full rigorous, comparison on benchmarks. But when we play with the data, we are seeing improved results. And I would say some of the data is not there. There is no exact test for it. So in my comment about being able to do a global search and then drill in, especially the semantic search, or excuse me, the more global vector search to kind of find a similarity area and then dive into using more specific graph queries. That the idea of combining those two things or acting the bridge, there's not an easy comparison out there, so it's hard to know. We can look at what it would be to hop between multiple tools, but I think we're getting some novel capabilities, which again, how do you prove they're better if they're novel? And then just performance in general has been fairly good, and we're doing this all on equipment that's out of our homes. So this isn't like fancy, well, it's expensive enough equipment for an individual, but it's not like super fancy lab equipment. So we're pretty excited about it. And as I said, people who do want to dive a little more into that, we do have some notebooks, and we'll definitely be sharing the updated notebooks in the next couple conferences. We're going to look at specifically the video and lexical information, or excuse me, image and lexical in the next our next session. And then at the Open Data Science Conference, we'll also be bringing in audio and providing some notebooks that people can kind of play around with a little bit as well. And so we're probably holding a little bit on the full notebooks until mid-May,
totally.
but just reach out to myself or anybody else, and we're definitely trying to provide more detail so people can go play with it themselves. I would just love to see what crazy things people come up with using this approach.
Yeah, absolutely. I think that's always the best, to see what people are doing, where this technology goes, and what people are building, and you take one idea and you take it to your space where you have the knowledge, and you adapt it there, and you create something that is really cool for that particular space. You adjust it, you adopt it, and then that's really interesting to see what's out there, and what creative things are coming from the technology, basically.
Yeah.
Cool. Maybe one more technical question because I see we are almost at time. Danny asks, because I think it might be an interesting question though, so I think that's why I tried to lead it out. Danny asks, are you dynamically building the nodes edges from the data, or how are you establishing what is a node or an edge? When we talked a little bit earlier, when you showed this little subgraph of the image, is that do you have a process for that you can share?
Yeah. So at the moment, it's not dynamically built, but we are looking at how updates would happen more dynamically, and whether we could build it. We are using a agentic workflow to do it, but to be able to, I don't want to say because we're lazy, but because it makes sense to automate as much as you can. But as far as dynamic updates on the graph, have not tried to tackle that yet. If somebody has a use case like that, like maybe that's part of the question, it might be interesting to speak a little further on, how we might be able to do that and what that looks like. So yeah, it's again one of those areas that I'm looking forward to, trying to see how we might do that.
Yeah, super cool. All right, I think that was a great session. Very, very interesting. Very, very informative. Thank you for giving us a little sneak peek into the upcoming conference presentations you will be giving soon. But also, obviously, it was great to chat and to discuss the concept of multimodal GraphRAG in itself,
Yeah.
and all these GraphRAG, graph linking concepts, linking data together. It's very interesting.
Awesome. Well, thanks for having me on, Alexander. Thanks everyone for joining. If anybody is in Boston, that's a next stream. So if anybody happens to be in Boston, we are hosting a meetup and a mixer. Neo4j is one of our sponsors for that. So come find us. And I don't know, Alex, or Alexander, if you've got the link to register for the Boston folks, that would be awesome.
Absolutely. I just shared that link in chat. So hopefully that is something you can join us. It should be also on the Neo4j meetups page. So if you browse there, you should be able to find it. If you are not in Boston or unable to attend this one, then the next stream we are having is in 2 weeks' time on the 30th of April with Jennifer on how to build a knowledge graph. So a little bit more hands-on, a good knowledge graph is the good baseline for a good graph or a multimodal GraphRAG application. So I think it's a good step to generate that. And before I let you all go, Nose is coming up. So if you have maybe for you, Amy, if you want to repeat that presentation in a more detailed way, then please submit to Nose. That's going to happen in November. The call for papers is now open. So if you have a cool graph story, please do submit. You have until the 15th of June. Submit your story, share your GraphRAG, whatever graph visualization. You have the full freedom of submit anything you like as long as it is graph related. So that's going to happen in November. But yeah, Amy, it was a pleasure. It was, as always, it's great to have you here. Thank you very much for joining this Neo4j Live today. And a good best of luck with the presentations at the Knowledge Graph conference, and hope to see you soon somewhere in the world of graphs.
Always lovely. Thank you, Alexander. Appreciate it. Thanks, everybody.
Thank you, everybody.